On to our next speaker, Vanesa Diaz of Corning Optical Communications, with a paper entitled Network Reshaped, 5G, Fronthaul and FixedMobile Convergence. Vanesa is Marketing Development Manager for Corning Optical Communications, responsible for developing competitive response for the EMEA market and specializing in fiber access networks for both mobile and MSO. Vanesa is a frequent speaker at international conferences and has authored several papers and articles in the telecommunication industry. Prior to joining Corning in 2010, Vanesa worked as a research and development engineer for RIMSA, an antenna and RF design manufacturer, and as a network supervisor for Vodafone Spain. Vanesa graduated with honours from the University of Cantabria, Spain, with a Bachelor of Science and Master of Science in Telecommunication Engineering. Vanesa also holds a Master of Business and Marketing from Griffith University, Australia. Vanesa, thank you.
All right, I think that my mom will be proud for that introduction. Thank you very much. I'm very grateful to be here. Thank you, everyone, for being here, especially after lunch and the wine. I'm very happy that the podium this time is low enough so I can actually see you and reach out to the phone. So the microphone, that's new. So I'm not going to talk about products today. I've actually brought a presentation that brings a lot of information with the ultimate goal of introduce you to the term of network fixed and mobile network convergence. But before we get to that point, I actually need to give you an overview on some of the concepts that are related to mobile networks. So we start from there. These are some figures that I've rescued from one of the GSMA reports that they've published this year. And it shows just the importance of mobile networks in the world. We know that not everyone has access to a fixed connection, but even in developing countries, almost absolutely everybody has a mobile phone. So it's a market that is growing massively, and we're not very much familiarized with it, besides being an end user, a customer. But it is massive. These are some of the figures. It's not only offering jobs around the world, it's not only making a lot of money, it's not only contributing to the GDP, but it also means a lot of money for mobile operators in terms of revenue. So that's the little square I'm highlighted there. So yes, the world is shifting towards mobile. Everything is going mobile. I agree with you. I have to say that it's mobile only at the edge, okay, because there is a lot of fixed network behind it. But yes, it is going in that direction. So when we look at these figures, this is from the European Commission, and we look at the telecommunication revenues by segment, we see that is actually the mobile data services, the segment that is growing strong, more than fixed networks. And that explains why, I'm looking now at the right side of the slide, the level of investment that is now going into mobile networks is actually surpassing the investment in fixed. So a lot of operators are recognizing this. We do need to go mobile. And that's why there are a lot of examples around the world of a lot of operators that recognize that they not only have to offer this famous triple play, they now to be able to offer the triple play on the move. And that's why we see a lot of operators merging and acquiring each other. And we see it from both sides. A mobile company that is acquiring a fix, it could be also an MSO, and vice versa. One of the closest examples I have from Spain is Ono and Vodafone that have now joined venture and they've embarked upon a very big war against Telefonica in Spain. Very interesting. So this is just to highlight the importance of mobile networks and why operators recognize the importance of it. So I need to explain a little bit how mobile networks work and a little bit of some very basic concepts like backhaul and fronthaul, so that we can go into convergence that is related with what I just explained. So a traditional backhaul link, what you're looking at here is a three-sectorial antenna. Imagine this is an urban environment. It's in the top of the building. Traditionally, these antennas are connected to the radio units, which is like the ear and the mouth of the antennas. And they were connected with a coax cable. Then we have the baseband unit, is like the brain of the antenna. And that brain, it works together with the ears and the mouth to send the information, but it also transmits information back to the central office, well, the mobile switch center. When we link this baseband unit to the mobile street center, we have this famous backhaul link. And all it has, well, it's typically 10 kilometers distance, is carrying a carrier Ethernet or OTN signal. And the amount of bandwidth that is carrying, it depends on which signal we are transmitting from the antenna. The more complex, so if we go to 4G LTE Advanced, which is the most complex signals that we have right now in the mobile market, typically for this antenna working at 80% capacity, we'll be transmitting back to the core of the network 80 megabits per second. The latency in these links is not particularly stringent. Is below, or it asks for something below 5 milliseconds. And so because of all these things, the amount of bandwidth that I'm carrying and the latency that is not too tight, I can actually carry this information using any of these 3 transmission mediums. I can use optical fiber. I can obviously use copper, but I'm going to leave that outside of the picture for now. And then I can use wireless solutions, microwave or millimeter, which is just different frequency bands. The 3 of them can be used. And we all have, when I started learning my research on this, I actually thought that the story looked pretty bad for optical fiber. But actually, that's not the case because everybody loves fiber and recognizes the need for it. So when we look at the amount of backhaul links in the world that are connected with one or other technology, we actually see that microwave is losing share relative to fiber. The number of backhaul connections in the world made with optical fiber are growing. When we look at what's happening around the world, actually the picture is a little bit more interesting because there are places like Asia Pacific where all the backhaul links are already optical fiber. The same in North America with 75%, and it's only EMEA and CALA, the parts of the world where we're a little bit behind. But again, shifting towards optical fiber. So in backhaul links, optical fiber is gaining traction. What about fronthaul? You've heard this term before, and I'm going to explain exactly when these type of links come on board. We start from the previous situation. We have my traditional 3-sectorial antenna in a city, and I have my radio units and my baseband unit both connected, co-located at the cell site. What the operators realized was that coax cable was wasting a lot of power that it could actually go into the antenna to transmit further distances and offering more bandwidth. So that's what they did. They moved the radio heads up, and now they are called remote radio heads. And now I connect them back to the baseband unit using an optical fiber link. So that link is more like a connection between machines in reality. Inside of that link, we have specific protocols. So what the operators are doing is moving this brain back to the mobile switch center. And this is when the fronthaul link comes. So what is it? It's the same distance again, because it's the same we had in a backhaul link. But what I'm carrying is that machine-to-machine protocol, CPRI or OBSE. The most common one is CPRI. And because this protocol is not designed for long-distance transmission, it's very basic. It's just sampling the signal and just throwing it there in the cable. The spectral efficiency of it is very low. And that's why in the same circumstances as before, rather than 80 megabits per second, if you remember, we were transmitting at the biggest or most complex case, the 4G LTE advanced case. Now I have more than 7 gigabits per second. That changes the picture slightly. Latency changes as well. I have the machine now back at the core of the network. There is distance in the link, and it's adding a lot of signal processing as well because of CPRI. That makes latency being more critical, and that's the reason why from 5 milliseconds that we had before, now I need below 200 microseconds. So it's a far more stringent latency requirement. This is the reason why in fronthaul links, the options that we have is optical fiber in the majority of cases, the only transmission medium that can cover these fronthaul links. Microwave can be used, but only for short links. So why would an operator go into the hassle of moving the brain and creating a fronthaul link if now it's going to demand optical fiber? The Asian countries are the ones, operators over there are the ones that are actually implementing this type of solutions. The benefits are many. And they occur when you actually do this in the same area with co-located cell sites. You put all the brains in the mobile switch center, and now what you have is that you can optimize or use much better the advanced feature of LTE, which is managing interferences between antennas. You know that the biggest problem with mobile antennas is that they need a frequency to operate, and that has to be given by the regulator. And there are a maximum number of frequencies that can be given, and if they want to buy more, it's really, really expensive. So if with what you have, you can actually reutilize them better because you're saving money. So if you put all those baseband units in the same place, you can benefit much more from reutilizing frequencies and get over interferences. So this is the benefit, the main benefit. You have heard about this as well. This is called Cloud Run. It's having just all the brains in the same place. But this also simplifies a lot the radio access networks. Now they are some kind of agnostic, so you can throw into those links whatever you want. And there is a very important reduction in CapEx and OpEx because you don't have to cool these units that were initially in the cell site. You have them all in the mobile switch center, so you can cool them all together. And the footprint as well, you don't have to pay for that footprint for that baseband unit in the cell site. They are all in your offices already. There is a final benefit, and I've heard this a few times already. 5G will need a very, very agnostic network. So by doing this, the operator makes sure that it's ready for when 5G comes on board. So 5G. Let's talk about 5G because I need to talk about this before I introduce convergence. We've heard a lot about this. It's still very vague information as can't see her now. There we go. There she is. You were talking about this before, about how vague is still the information we have on 5G. It's a technology that will not be deployed until 2020 minimum. So it's still up in the air. We heard things that it's going to be able to do many different things, like connecting vehicles all over the world. We will have a lot more bandwidth, wireless bandwidth. These are some of the examples. But actually, what 5G can do is more than all these things we do, and I like to picture this as little different subworlds. It's a very, very, it's meant to be a very versatile technology. So we can, I like this sketch because it just shows three different massive applications of it. So you could use it for ultra-reliable machine-type communications, extreme mobile broadband, or massive machine-type communications. And depending on what you need, you can actually shape 5G to give you that. So you can have many, many little different connections, like thousands of little bandwidth connections. You can have one connection that it gives you a lot of bandwidth, and so on. But if you look at all these different applications of 5G, they all have requirements in terms of bandwidth and in terms of latency that are very stringent. That's the reason why 5G is going to need a lot of fiber. I'm comparing here very roughly, okay, 3G, 4G technologies versus 5G. 3G and 4G is going to use the same frequency range, is using, while 5G is going to change. And depending on the frequencies that we use, we will have bigger or smaller antennas, and we will aim for those little connections with small bandwidth or one massive connection. We will have different antennas, as I said, depending on the frequency used and the use they want to give them. We will have the possibility of have multi-beams. It'll be flexible, which is what I was trying to say before. And the concepts of backhaul and fronthaul will completely disappear. I've heard something called crosshaul. And to be honest, I don't know exactly what it means, still very vague. But what's for sure is that 5G is going to need a lot of fiber. And this is basically the reason why convergence, network convergence, is starting to gain traction. So far, what operators have been doing is deploying completely, separate from each other, the mobile network versus the fixed network. And what's happening now is that, yes, fixed networks can share resources, they can use PON, but mobile networks cannot. They've been using dedicated resources, and with 5G coming on board, with small cells coming on board, with more resources needed and more fiber needed, using dedicated resources is no longer sustainable. We also saw at the beginning that operators around the world recognize now the importance of being able to play in both markets, fixed and mobile. So what we have now are one massive operator that is seen at both networks at the same time. So the concept of network convergence is not new at all. I think it first was defined in, 2004 by the Network Alliance, and since it's just been out there flying in the market, and it's starting to gain traction now because of all these reasons, and particularly because fiber is needed more than ever before. So let's look at more in detail to what fixed mobile convergence means. There is a European organization called Combo, and they've been researching on this topic for a year. So this is a very simple schematic about how the networks look like now, with both the fixed and the mobile operating separately. And this is what they think it can happen if you actually blend them together into one. You have one access network that is neutral. It can be used for both. And then network elements at the end that they're supposed to be completely transparent as well. The idea is that the operator can actually orchestrate or operate this network as one, no matter what they're running through it. And so the resources can also be reutilized. So I don't have to dedicate hardware. I could use the same hardware for both, and even the signal, which is what I'm going to explain now. So after months researching, because the convergence story is quite messy, to be honest. Everybody talks about it, and everybody refers to different applications of it or parts of it. So this is what I found out. I found out that there are 3 basic levels. This is my idea, so please do not disclose this because I might be wrong. At the functional level, this is what you hear most of the time when you go to a conference and people talk about mobile fixed convergence. They are referring to functional, and it means that I get my phone and I can use it outside connected to an antenna, or I can use it inside of my house connected to my modem. It's completely transparent, and there are other applications I'll show you later. But there are more intimacy convergence of fixed and mobile networks that happen at the network layer. At the hardware level, we could be sharing cables and cabinets and connectors and ODFs and so on. And even deeper than that, at the signal level, we could use the same signal to carry both the information that is going to a customer in the house and the information that is going to me that I'm outside in the street with a mobile phone. So just for you to understand what all these different types of convergence means, at the functional level, these are some examples shown by BT in the 5G conference this year in London. Dynamic bandwidth allocation. This means pretty much that my modem can benefit from using the macro cell site or the small cell site that is nearby in case of failure, for example, and vice versa. So one network backs up the other one. Reuse of infrastructure for small cell deployments. We've heard this. Small cells are pretty difficult to connect to the network. It's basically the barrier to market of this technology. So one possible solution is, rather than connecting them by deploying the cable and reaching out to them, we could connect them to the fixed fiber infrastructure that is already in place. And then network sharing. If I have a network that is completely neutral, and some operators are doing it already, I could rent some of my network to, imagine I'm a fixed operator, but there is a mobile operator who needs to connect whatever, and I can actually rent my network to them. So it could be done a proper sharing of it. If we keep on traveling at more intimate levels of convergence, at the hardware level, this is something I've spoken to many operators, and they confirm this is actually something that they've been doing for a while now. They get to an area and they have to connect a macro cell site, and there's already a fiber to the home PON network already deployed there. Why not pull in some of the cables out and connect that macro cell site? That's actually pretty common. It's happening, it will continue happening. But there is other convergence that is at the deepest level, is at the signal level. It's very complex, and is where the discussion, at least for the Combo organization, is taking place at the minute. This means that what I'm doing is basically I'm trying to show here the difference. So what we're looking at on top was the convergence at hardware level. What I was doing is just pulling a cable out. And what I'm doing at the signal level is truly using the same protocol to connect whatever is at the end of the network. So why this is so relevant? Because it's actually very, very hard to do. Because at the end, what I have is many different types of end user cases, not only the ones that we are very familiarized with, fiber to the home, fiber to the business, fiber to the cabinet. I also have now all the different options with requirements that mobile networks have. We talk about backhaul and fronthaul links. And what you're looking at here is a sketch that shows that actually fronthaul and backhaul could mix up as well. So it's an extremely complex case, and it's not an easy problem to tackle. Combo organization, what they were doing, or they've been doing for the last year, is looking at different technologies to connect all these things at the end of the network. You could look at deploying one fiber and use the wavelengths, dedicated wavelengths, to connect the different elements at the end of the network. You could look into NG-PON to WDM overlay over the network that you already have. You could use TWDM PON solutions and then connect everything there. And then wavelength routed DWDM PON. I'm not going to go in detail with these types of solutions because it's messy, it's complex. I just wanted to let you know that the protocol that is actually winning this race at the minute is TWDM PON. And this is actually what Combo was showing in their last presentation. This is how a fronthaul, this is a network that has fronthaul on it. So what you're looking at there is, I would like to move, hold on. Okay, well, at least I made you laugh. Now you're awake. So I wanted to point here, but it's not working very well. Why is it not working? Not working. What you have is, in that side of the slide, what you have is the different options, the different end users that you can have, okay? From the fiber to the home end user, fiber to the cabinet, and then if we go up, we see small cells. We have a Wi-Fi hotspot, a small cell, and a macro cell site. And this is showing how the networks would look like in the future. It's an operator that is also doing fronthaul, so that's the link that you have at the very top. You can see it there. How they will be connecting all these things with separate networks. So you have they're using CWDM to cover this fronthaul link, and then as we move down, you see that they have a separate OLT for NG-PON or GPON network there at the bottom for traditional fixed networks. And what Combo suggests, one possibility, one truly converged network, how would it look like? Well, if we use NG-PON2 with point-to-point WDM, for example, what we will have is everything unified. Now we have everything in the same, with same OLT coming from the same place. So we do have point-to-point WDM to connect the macro cell site, but TWDM, that I was mentioning to you before, protocol, to do the rest of the job. So I'm not going to go in detail with this because I just wanted you to know pretty much the existence of convergence. We in Corning, we believe that networks are going in this direction and is slowly but surely finally gaining traction. The moment is now because it's when mobile networks need more fiber than never before, with 5G as well coming on board. And so pretty much this presentation wanted to introduce you to the work that we've been doing in Corning. And if you come across any convergence topic or, I don't know, situation, would very much like to talk to you because we are very, very much interested in this. I hope you've learned a little bit, and thank you.